Well, hello everybody. Happy Thursday. Sorry I can't be with you today, but at least I can go ahead and give you this video to watch to help you guys look at a few problems that you can take notes on, and that you can also go ahead then and try to use the same technique on some problems today after you've watched this video. So what you should have in front of you right now is you should have a copy of these notes. Okay, if you have these notes, you should be ready to go, and we're going to get started here today. So today you're going to go ahead and take the polar plunge into working with polar equations. Okay, now we've already kind of looked at the graphs of those and somewhat, and today we are interested in finding just part of the graph, just making part of the graph show up, not all of it. So you need to follow along with these, okay, and hopefully this will make sense to you. So we're going to go ahead and jump right in here, see what's going on. Let me get us to the next page. So our next page is this. So this is what you have in front of you. And here we have a beautiful rose that has already been graphed. So here we have the graph of r equals 4 sine 3 theta. And if you recall from our notes that we took on Tuesday, this has 3 petals because n is an odd number. If it was an even number, we would have twice as many petals. Okay? But this one being odd, we're only going to have the same number. So we have 3 petals. Also, remember that this number in front, the 4, gives us the length of each petal. It's the radius. So this distance from here to here is 4. And you can see there's a 4 right here. All right, so here's our goal. Our goal today is to find out what values of theta will graph one petal. I want to have some values of theta. So I'm going to write it over here. What values of theta will graph one petal? That's the question we have today. So if I'm going over here, that means I want to be able to go ahead, and let's take our highlighter, and let's say I wanted to go ahead and just know how would I end up with just a graph of this piece right here. That's what I want. This one petal is what I want to go ahead and look at. So what do? Well, notice that this petal right here, this petal is attached at the pole. All of the petals are attached at the pole. And we should know that at the pole, the radius r is equal to 0. That makes sense. If you're sitting at the pole, you're at the center of the circle, the radius is 0. So let's look up here at this equation we have. We have r equals 4 sine 3 theta. I need to know, when does this equal 0? That's my goal. I have to find that out. So this is going back to what your last test was on. Your last test in here was on solving trigonometric equations. That's all you're going to do right now is solve the trigonometric equation of 4 sine of 3 theta equals 0. We're going to solve this. Now, sometimes when you're solving these, your answers will be familiar angles from the unit circle. Sometimes they will not be familiar angles, and you'll have to use your calculator to get an approximation. So let's try this one out and see if it's a familiar angle, or if we're going to have to use that calculator to get an answer for it. First step here, I need to isolate the trig function always. Divide by 4, so I get that the sine of 3 theta is equal to 0. This is a nice one, I can already tell. So my question is that when is the sine function equal to 0 between 0 and 2 pi? And the answer is the sine is equal to 0 at 0 and pi. Right? Now, that's not what theta is. That's what 3 theta equals. 3 theta, the angle 3 theta is equal to 0 and pi. What do? I divide by 3. So now I get that theta equals 0, comma, pi over 3. Now remember, that's not all of the solutions. This value right here, this value, remember it changes the period. it changes how many cycles it will go through between 0 and 2 pi. Usually it's one cycle between 0 and 2 pi. This, if you recall, is a horizontal compression, so it's going to go through 3 cycles between 0 and 2 pi. What would I do here? I have to know what the period of this function is. The period of this function is 2 pi over 3. So to get my remaining answers, I would add 2 pi over 3 to this one. I would add 2 pi over 3 to this one. I would add 2 pi over 3 to this one. That's going to give me 4 pi over 3. And then I would add 2 pi over 3 to this one, which is going to give me 5 pi over 3. So now all of a sudden, these are all of my solutions. All right? Now, I'm going to go ahead and go to my calculator. I'm going to call up this graph, and I'm going to go ahead and restrict the values of theta to these right here. Those are the ones I'm going to use, 0 and pi over 3, and let's watch what happens. I'm going to come over to my computer here, and I'm going to call up this graph. So let's open this up. So here is this original graph, and we want to restrict it between 0, if you recall, and pi over 3. So I'm going to go ahead and go here, special brackets. I want to go 0, pi, and then this is theta, and pi over 3. And in doing so, boom, you will notice that just the first one shows up. Okay, the first one shows up. Then if I go, I could do one of the other ones, but this is all I needed. I just wanted to go ahead and find out what values of theta between what and what will one petal show up. So my answer is between 0 and pi over 3, I can create one of my petals. So that would be my answer on this particular problem. Every pi over 3. Now that's not the only one. I could go from, let's watch this, pi divided by 3 to 2 pi divided by 3, and I get a different petal. Or I could go from 2 pi over 3 to pi, and I get this petal. So every time I go ahead and go a pi over 3 range, 0 to pi over 3, that's one petal. Pi over 3 to 2 pi over 3, that's a second petal. 2 pi over 3 to 3 pi over 3, which is pi, another petal. 3 pi over 3 to 4 pi over 3, another. There we go. That's what we're doing here, right? So now we have that very first one, and it is done. So here it is. So our final answer is to create this petal, theta is greater than or equal to 0, less than or equal to pi over 3. Boom. That's the very first one. And I could use any pair of consecutives. I could use these two, these two, these two, these two, these two. It's my choice what I want to use. Okay? You will get to try this today. It will be a very similar style of problem. Right? So, let's go ahead. We're finished with this one. We've taken care of our rows. Let's see what kind of problem I have for you next. Oh, look. Beautiful. It's a what? It is a dun, 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 dun. It's a limousin, okay? All right, so here I have a limousin. Now, what were the things about this we had to remember? Hopefully there's some things you remember about this. First of all, if it's sine, it's symmetric to the pi over 2 axis, which this one is. Since it's a negative sign, it's going to be below the polar axis. This is where sine is negative, all right? What else do we know? If you add the 2 and the 5, their absolute value, 7, that's how far out it comes. So this is 7 right here. If you subtract those, 5 minus 2, that's 3. That's the distance of the inner loop from the pole out. And then this first value here, 2, is where it crosses the non-symmetric axis here and here. So those are some things we did from yesterday's notes. Now, what is our goal today on this one? Well, same idea. I want to go ahead and take this graph, and I only want the inner loop to graph. Okay, so what values of theta will graph just the inner loop? So let's highlight what we're looking at graphing. So we want to graph this piece right here. We just want this part of the graph to show up. Okay? Now, again, what do we notice? Well, it looks to me like this is where? Yeah, you got it. It's stuck right here at the pole. It's attached at the pole, which means that r is equal to 0. Boom. So I need to go ahead and solve this. I need to solve r equals 0. All right? So let's go up here and replace it. We're going to have 2 minus 5 sine theta. And that is equal to 0. Now I have to solve this trig equation right here for theta. First step, subtract 2. Divide by negative 5. So we get that the sine of theta is equal to 2/5, which is 0.4. That is not a familiar angle. So we're going to have to use our calculators for this. Now real quick, let's think about this. Step out of the polar zone for a second. Step back into the Cartesian rectangular coordinate system real fast. In what quadrants is the sine positive? Okay, sine is positive in quadrants 1 and 2. That means my angles are going to be up here and here. And if I were to go ahead and do this, watch how this works. If I look at this loop, if I come back here like this, and as soon as it hits the pole, if I went straight out, this is one of my angles right here. This is one of my angles I need. The other one would be if I traced the inner loop the other way and came straight out. This is the other angle I need. I need the one that goes from here to here. Because this inner loop right here is formed between here and here. This is what's forming this inner loop. As theta goes from here to here, this inside loop is going to be formed. So I need to know what's this value of theta and what's this value of theta here. I'm here now. All right, so what do I have to do? I need to go ahead and find what is the inverse sine of this. So theta is the arcsine of 0.4. And let me grab my calculator real fast. Go ahead and do this. Second sine of 0.4. And I get that theta is approximately 0.412. We're just going to take it out to the nearest thousandths. So that means that this angle right here, this reference angle, this is an angle, this from here to here is 0.412. That means that this angle right here of theta is 4.412. So we're going to start at 0.412 and we're going to end here at this second value of theta. Okay, well, if this is 0.412, this angle between here and here is also that. This is the reference angle. This is 0.412. But since I'm going to go this direction, this theta 2 is pi minus 0.412. So it looks like this region right here, this yellow region, theta is going to go between 0.412 and pi minus 0.412. Let's go to Desmos and see if I restrict the values of theta, if this is the only part of the graph that shows up. So let me go over to my desk. And we're going to just turn this one off and turn this one on. So here is our limacon. Okay? So we just said we wanted this to go from 0.412 and pi minus that. And lo and behold, boom, look what we get. We get just the inner loop. There it is. Now, you might be asking, why would I want to do this in calculus? Why is Mr. Schneider worried about finding this? Because what's going to happen is next year, okay, oh, that's going to just keep doing that. Next year, it's going to want you to go ahead and find this region so that you could find the area inside the region. In order to find the area inside this region here, you have to know where does it start being formed and where does it stop being formed. And that's all about finding those values of theta. So this is why we're doing this. We're doing this so that we can find a particular enclosed region so we can find the area within that region. That's what you're going to be doing next year, potentially, in Calc with Mr. Mitter. I like that problem. I think it's time to try the last one. This is the best type. I love this last type. They are by far my favorite. So let me go ahead and get rid of this ink. Got on here real fast. Let's just clear it all out. Clear ink. Great. All right. Last problem. So this one we just finished up. There it is. We've got one to go. So that was a limacon. Okay. Last one. Here we go. All right. Look what we have here. We have two graphs this time. We have two. Okay. We have r equals 8 sine theta. That is this orange circle right here. This is the orange circle. Then we have r equals 2 plus 4 sine theta. That is this limacon that is black right here. Okay? I want to find the following region. I'm going to get my highlighter here. Highlighter. Boom. I want to find the values of theta that would create this part of the circle and create this part of the limacon. Because between those two regions is this beautiful crescent moon. Look at that crescent moon in between there. I want to be able to find the area of this crescent moon. Well, I shouldn't say I want to. Next year, you're going to want to be able to find the area of this crescent moon. In order to find that, I have to find out what values of theta create these two pieces of the graph. That's going to be my goal. Now, this one's different in that this is not where it's attached at the pole. Okay? This is not at the pole. This is not at the pole. So the radius there is not equal to what? Yeah, it's not equal to 0, so I can't just do that. How am I going to do this? Well, what do I know at these locations? At this location here and at this location here, these two functions have to be equal to one another. Those two polar equations must be equal because they're intersecting there. So instead of setting one of them equal to 0, I am literally going to set this 8 sine theta equal to 2 plus 4 sine theta and solve for theta. Let's do it. Here we go. 8 sine theta equals 2 plus 4 sine theta. So again, remember, we're trying to find out what values of theta create the crescent moon. That's my goal. Which values of theta create the crescent moon? So I've got a value of theta here, and I've got a value of theta here. I need both of those because from here to here is when it's going to be formed. We're going to solve this now. What do I want to do? Get my function or get my trig function on one side of the equation. I'm going to subtract 4 sine theta from both sides. So here I get 4 sine theta equals 2. Divide by 4. Sine of theta equals 1/2. That's a familiar angle. I love that. What are my values of theta? Theta is equal to pi over 6 and 5 pi over 6. Now, if I went ahead and drew from the pole, let's draw these, this is pi over 6, and this one from here to here, this is 5 pi over 6. So it looks to me like this region right here, that this yellow region would be formed if theta is between pi over 6 and 5 pi over 6. Let's check it out on Desmos and see. Last one on Desmos land. All right, so we'll turn this one off. So we'll turn these two on. There they are. So we just said we wanted to go from pi over 6. Okay, oops, back that up. Get out of that. And pi over 6. And 5 pi over 6. Notice when I did this, okay? Notice that when I repaste that, you'll see part of the orange circle disappear. Now I'm going to take that exact same thing and paste it down here. And voila, look what we have. We have just this top piece showing up. Here is the crescent moon that we wanted to find. That means if we can find that, next year you can then find the area bound between these two graphs. And that will be your goal next year with Mr. Knitter. All right? So, you're going to be doing some problems like this today. All right? Follow along with these. Hopefully you have written this information down on your note packet that you can go ahead and use it. When you get your answers, you should graph it in Desmos like this to go ahead and see if you are finding the region I was asking for. If it doesn't work, you need to check your answers, because that's how you'll check to see if you have it right or wrong, by graphing it and then restricting the values of theta like I have up here. All right, so guys, that's it. Hopefully you guys will understand this and you'll be able to do it. When I come back on Friday, we will go over the problems you're going to do today, and then we're going to do some extra ones for practice to prepare for Monday. All right, so guys, thank you very much, and I will go ahead and see you guys tomorrow.